Okay, hi and welcome to video notes 9.5 and 9.6. We're going to kind of combine a couple of things today and do them a little bit different than the book. But today we're going to be able to work or change a trinomial into a four-term polynomial, and we're also going to work with factoring our version of our polynomials right now, which is ax squared, where a is 1, bx plus c. So that's kind of our goal. Those two things, if we can get out of this, that's great. So let's go ahead and get down into this real quick. We are familiar before we start with one thing prior to this, which is the GCF. Okay, and we know that that is a form of factoring, right? So we know that that's some form of factoring, and in doing that, it is a division. It's key to remember when we say the word factor, we really mean division, kind of one and the same. Just like when we say multiplication, it really means the distributive property. So let's keep that in mind. So first example here just wants to take us from factored form. Okay, two polynomials here, two binomials being multiplied together. We would use some form of distributive or a box there, and we'd multiply it out. We get something that looks like this. Hey, it kind of looks like a four-term polynomial. But wait, we're going to work backwards to that. Okay, we're going to start here and go to there. But so if you look at that, we do x times x squared, x times 8, 8x, 4 times x, 4x, and 4 times 8 is 32. So we know that those are all multiplying together, and we can follow those arrows to get there. And then we're going to go ahead and combine these like terms, and we're going to get that middle linear term there. That's something you should be familiar with. But let's see, since our concept is to go backwards through division, right, not percentage, and see if we can find any patterns here. Well, we know that these two numbers here, right, 8 and 4, multiply to make this 32. So if we can get some factors of 32 here, if we could figure out what those factors were, we could essentially kind of go back to 8 and 4. We'd have to find the right ones because there's more than one set of factors that make 32. There's actually quite a few. So if we could find those, we could maybe work backwards. Another pattern that we might be able to see here is that these 8 and 4 that we have, they kind of make our linear term, especially when the x multiplies to the 8 and the 4 multiplies to the x here. They make our linear terms, but they seem to be an addition of our terms here. So if we could find these particular factors, they'll multiply back. Let me grab that green color again. They multiply back to get to those factored form. And then we could also, they have to work to make this addition or this middle term. So whatever two factors we find of 32, it looks like, they have to add to that middle term because that's what's happening here. So let's just kind of review that. Okay, remember, factor is division, means we're going reverse, or reversing multiplication, we're going backwards. So just in that particular example, if we had those products of that value of 32, that c value in our terms, ax squared plus bx plus c, if they were to multiply to make the c value, but add to make the sum, to make the middle term, then we can essentially factor. So if we can find the factors of the third term, we can factor, is what we're going to say here. So let's look at one. So looking at this first one here, we'll leave it right about there. I think we got to the spot that I wanted. If we look at this one, we're in a trinomial. We're a quadratic in this case, but that's fine. We've got three terms. Excellent. We said if we could find the factors of 24 here that would work, that they sum to 11, then we could factor this back. It looks like we could do it. So I've written out all the factors of 24, and this will be something that you want to do regularly, especially until you get your number sense underneath you. But if we look, some combination of addition of these needs to get to 11. 1 and 24 is not going to do that. 2 and 12 is not going to do that. But 3 and 8 looks like they will. So these two factors here will multiply to make 24 and seem to add to get back to that 11r. So let's go ahead and take a look at that. So if we wanted to write that, let's go back to the previous problem. So we know it's 3 and 8, right? And this is 4 and 8 in our example, right? So they add to that middle term of 11 here, just like they added to 12 here. We should be able to go right back into that factored form. So what I'm saying is we should be able to take, instead of x this time, it's an r, right? Because there's an r there. We should be able to take an r, right? And we're going to go ahead and put plus 3. And then we're going to take that r and put plus 8. Because they're both positive in this case, they have to add to 11, right? So if that's true, then we should be able to check this by multiplying it back out using our distributive property. So let's do that. R times r squared. R times 8, 8r, positive 8r. 3 times r, positive 3r, and 3 times 8, which is our 24. These should be like terms, and even though that looks like a v, it is an r. They are, so we end up with r squared plus 11r plus 24. So hey, look at that. Great job. We just factored. Here's another example you can take a peek at again. We looked at that c value and we said, hey, here's all the factors. 3 and 4 will add to that middle term, so we were able to take x plus 3 and x plus 4. Again, multiplying it back out, we were able to get back there. That's a nice check to do right now. But wouldn't it be nice if there was a little technique that we could use to multiply to that? And we have one, so let's check it out. Okay, so here's a little technique that'll help us find that product and that sum a little easier for us and get us organized. Additionally, it'll also get us to 4 terms. Let me write that out. Okay. All right, so first thing you want to do is make yourself a little x. Okay, and that's just going to help us stay organized. In the top, we're going to put the product. The product is a times c. And the reason that we want a times c is that eventually a will not be 1 like in all of our examples. And the bottom is going to be the b. So we're going to put those in there to help us kind of organize our thoughts. And then on the sides, we're going to put the factors. You can see that here. So let's take a look at what that looks like for this example here. X squared plus 7x plus 6. So a times c, or 1 times 6, is going to be 6. And I usually write a times c at the top to remind me. And b then is our middle term, and 7. Remember, it's imperative that you only use the coefficients. No variables are included in this process. All right, so now that we've got that, what two values or factors of 6 will work? Well, there's only really two factors, or two sets of factors of 6, 1 and 6 and 2 and 6. The only way we're getting to 7 is if we take the 1 and 6, and they're both going to have to be positive here. So positive 1, positive 6. Now, it's a nice little way to organize everything there, and we can see everything that we need. What that gives us and how we get to 4 terms then, you can see that's what was worked out right there, by the way. What that allows us to do is it lets us break up that middle term that would come from our polynomials. So when we would combine them, these would be like terms. That's what these are. These are the two factors that let us get back to factored form. So essentially what we can do then is write those two factors in right from our polynomial. We take that middle term and we break it up into these two factors. So it should look like this, right? It'd be 7x plus 6. That's the original polynomial, but this step in between lets us get here, which then allows us to get back to that factored form. Now, more importantly, this step in the next section of notes, when we go to find ax squared plus bx plus c, where a is greater than 1. I think I did that backwards. A is greater than 1, meaning it's a value other than 1. That's where this part will become more important. But for today, we can actually just skip that step and we can go back and forth because a is 1. We're able to jump right back from factored form to polynomial form after we do our x and see the factors that actually sum to the correct value. All right, let's move on to some examples. Okay, so we're on the next page here. We're going to do a couple examples of these. Make sure you pause and write these down, and we'll do one together in a second. But first, let's take a look at one of these examples here. So here we are in a trinomial. Again, it's quadratic, just happens to be. Really, we're only going to be factoring mainly quadratics anyway with this method. Also notice that our a values for all of the quadratics that we're looking at here are going to be 1. Different process tomorrow. All right, with that being said, make yourself a nice little x like this. Then you're going to take a times c. You're going to put that in the top of the x, which is the 15. You can see that there. Remember, you're going to take the middle term, b, put it down at the bottom. And our goal with this is you're trying to find the product, that's why there's a multiplication there, of 15 that sums or subtracts to 8. In this case, we're going to start out by listing all of our factors of 15, and there's only 2, 1 and 15 and 3 and 5. So it makes our choice pretty simple. In this case, we're going to find out that 3 and 5 are the two that work. We should note that these are both positive. That won't always be the case, so make sure that you watch for that. Exactly like in example C here. So we're going to do the same thing. Oh, I'm sorry, forgot to finish up. You go ahead and write those in, x plus 3, x plus 5. You should take those two factors today. So we're going to do one from scratch. Here it is. We're going to put in the top here. Let me grab my right color. We're going to put on the top a times c, which is 1 times 6, or 6. And this time we have to sum to a negative number. That's okay. The process is still the same. So what are the factors then of 6? Well, again, easy set, 1 and 6, 2 and 3. But when we do this one, our goal is to get some combination of these to be negative 5. Well, 2 and 3 will add to make positive 5, but not negative 5. We could, however, do -2 and -3. And if we chose -2 and -3, so let's highlight them because I think that those are going to work. If we highlight those, -2 times -3 will make a +6. And if we add them together, two negatives will become more negative and make a -5. Now, if you look at the other one, just to kind of make sure that you're like, well, wait, 1 and 6 could make 5. You're correct, they could. And to make a -5, this one would have to be negative, correct? And then we'd have to add a +1. The problem with this one is, and you need to pay special attention to this, is that 1 times -6 is not +6. So it's important to know what your signs are for this. So in this case, a -2 and -3 are the only ones that work. And really, there is only one set of factors that will work for this factoring. It's also noted to say not all are factorable. So you're going to find some that won't have any combination of factors that multiply to a times c that will sum to the middle. And then you just say they're not factorable. All right, with that being said, let's go ahead and write down what it's going to be. We're going to take our variable x and we're going to subtract 2. And then we're going to take x and we're going to subtract 3. And those are our factors. And again, if you want to multiply it out real quick, x times x squared, x times -3, -3x, -2 times, oops, forgot to do that, -2 times x, -2x, and -2 times -3 is +6. That's going to be x squared minus 5x plus 6. It's always good to check those just to make sure you're doing it right. Okay, so let's look at two more examples here, but you'll notice in both of these, quadratic because they're squared, trinomials, 1, 2, 3 because there's 3 terms, but notice something's different. We've got another variable involved. There's a k involved here in a k squared, and there's a y and a y squared in this one. So what do we do with this other variable? Well, what we're going to do is we're going to wait on it. We're going to ignore it, okay, for right now. And we'll come back to it. So our process is exactly the same as we did above, but we'll put that k in, or the y over here, in right afterwards. All right, so let's go ahead and proceed like we know how to do. We're going to take a times c, so 1 times -77. So we're going to find the factors of -77, which is going to be 1 and -77, or I'm just going to put 77 for now. Factors, the sign doesn't matter. Right now it doesn't. And we're going to put in 11 and 7. So we need some combination that's going to multiply to -77 that's going to combine to make -4. So we know that whatever the number is, the larger one, because the sum is negative, has to be the negative one. So if we look at 11 and 7, they look like they'll make a 4. Actually, more importantly, the 11 has to be negative and the 7 has to be positive because they'll combine to make a -4. So let's go ahead and put those in. So there's our signs. So we should be able to go right into writing this, right? And we're going to pretend nothing's different. So we're going to put an h just like we had out front. We're going to put our factor. But this time at the end of our factor, we're going to put that other variable there. So we're going to put a k. And on this side, I'm going to do the same thing. And I'm going to put a k as well. We put that 7 right in there. So let's check by multiplying this out. I'm going to switch colors here. So I'm going to take h times h, which is h squared. I'm going to take h times 7k, which is going to be positive hk, 7hk. Now I'm going to do the -11, -11 hk. And I like to put them in the same order. So, and I always like to do the alphabet down the list here. So I always put h before k. And then I'm going to take -11k times 7k, which is going to give me -77k squared. These are like terms. We're going to go ahead and combine them. It's going to give me -4hk minus 77k squared. And then that is your factored form. Okay, so by ignoring that variable there, because we know that we're just going to tack it on, just like the h's multiply to make h squared, the k's are going to multiply to make k squared, so they have to be on the second term. All right, so looking at this one, though, I want to pay attention to something here real quick, because there's a little bit of a pattern. If you notice that our values here, let's look at these signs. Here's a negative, and we notice we've got some negatives here as well. Let's see if we can find a pattern with these. We've got 2 negatives here, that's fine, but let's look at this one a little bit closer. The c, our last term here, or our c value, and when I say c value, I'm talking about ax squared plus bx plus c, so our constant, and this one happens to be negative. And for that to be negative, right, that means that one of our two factors also has to be negative because we're multiplying to make this. So I forgot to put that negative there. So if I put that negative there to make this -48, one of the two factors, in this case, one of these two has to be negative. So if you have a negative c, one factor has to be negative. Notice over here, to have a negative middle term and a negative back value, one also has to be negative. Okay, but there's a possibility that when you have a negative middle term and a positive back term, that they would both have to be negative. So what I'm getting at here is that if you have a negative b, these are just nice little patterns that you can remember. You don't have to memorize these, but they're nice if you can recall them. That if you have a negative b, or that middle term, again, I'll write it right here, ax squared plus bx plus c. If this value right here in the middle is negative, then both factors have to be negative. As long as c is positive. We should probably have that in, especially if c is positive. So if you have a negative b and a positive c, then both factors have to be negative. It's the only way that that'll work. And if you have a negative c value, one factor will be negative. Again, nothing more than a little trick once you get that under your belt to pay attention to. Okay, thanks for watching. Today, just to recall, we were able to break these up into 4 terms. More importantly, we were also able to factor ones with an a value of 1 here. That was everything that we did today. So a equals 1 on everything that we did. If we switch back to the other page, we were also able to break these up into 4 terms using this x value here. We didn't do a lot of that, but we were able to. And tomorrow we're going to use that. So that's really where that's going to come into play. So you were able to break up into 4 terms, and you were also able to factor ones with an a value that are equal to 1. All right, thanks for watching. We'll see you next time.